Look up at the night sky for a second. Every tiny point of light you see is a sun, many of them bigger and brighter than our own. Now think about this. There are hundreds of billions of stars in our galaxy alone, and billions of galaxies beyond that, each overflowing with stars. With that much light pouring through the universe, you'd expect the sky to blaze like a cosmic floodlight. So why, when you step outside on a clear night, do you see an endless black ocean with only a faint sprinkle of stars? This isn't just a casual fun fact. It's a puzzle that kept scientists awake for centuries and even challenged the idea of an infinite, eternal universe. The darkness overhead isn't empty at all. It's a clue to how the cosmos was born, how it's stretching apart, and how most of its light is hidden beyond human sight. The night sky looks dark, but the reason it stays that way will completely change how you think about space itself. Back in the 1800s, German astronomer Heinrich Olbers put a simple but unsettling question on paper. If the universe is infinite and full of stars, why isn't the night sky as bright as the sun? Think about it. No matter which way you look, an infinite universe should eventually line your sight with a star. The combined glow of countless suns ought to paint the entire sky white hot. Earlier thinkers like Johannes Kepler had noticed the same contradiction, but Olbers turned it into a full-blown paradox that baffled astronomers for generations. If their assumptions about an endless, unchanging universe were correct, darkness simply shouldn't exist, but the mystery didn't stay unsolved. The search for an answer would uncover clues about the universe's true age, its restless expansion, and why the light from distant stars never reaches our eyes in the way we expect. For a long time, people imagined the universe as eternal, stretching backward in time without a starting point. If that were true, every patch of the sky would have had infinite time to fill with starlight, and darkness would be impossible. But the 20th century flipped that idea upside down. Discoveries like Edwin Hubble's observation of distant galaxies revealed that space is expanding, and that expansion points to a dramatic birth, the Big Bang, about 13.8 billion years ago. That number changes everything. Light travels incredibly fast, nearly 300,000 kilometers each second, but even at that speed, it can only cover so much ground in a finite amount of time. Picture galaxies so far away that their first rays of light are still racing toward us, billions of years after those stars formed. Their glow hasn't had enough time to bridge the unimaginable distances. To our eyes, it's as if those stars don't exist yet. So the night sky we see is like a photograph taken mid-exposure. We're catching light that began its journey eons ago, while the newest photons from countless other stars are still on the road. This single fact slices Olbers' paradox in half. The sky isn't ablaze because we're only witnessing a small, time-limited slice of the universe's true brilliance. But that's only part of the story. Even the ancient starlight that has had time to arrive carries another surprise. Space itself is stretching, and that cosmic expansion quietly steals even more of the universe's visible glow. The universe isn't just sitting still, it's stretching in every direction like an ever-inflating balloon. Edwin Hubble's observations in the 1920s showed that galaxies are racing away from us, and the farther they are, the faster they flee. This expansion does more than increase the distance between stars, it stretches the very waves of light they send out. Here's why that matters. Light travels in waves, and when space itself expands, those waves are pulled apart. Their wavelengths grow longer, sliding from visible colors into the infrared and even into the faint microwave spectrum. Astronomers call this effect redshift because the light literally shifts toward the red end of the spectrum, and then beyond what human eyes can detect. Think of it as cosmic dimming. A brilliant blue star in a distant galaxy might pour out intense visible light, but by the time its photons cross billions of light-years of expanding space, that glow has been stretched into invisible heat radiation. The light is still there, just shifted into forms we can't see. This constant redshifting means that even the oldest starlight we do receive arrives weaker and less visible than when it began its journey. So the universe doesn't just limit how far we can see, it quietly drains the brightness of the light that makes it through. And yet, expansion and age alone don't fully explain the velvet blackness overhead. Something else, something floating between the stars, helps hide their combined glow even more. Even when starlight survives billions of years of travel and the stretching of space, it still has another obstacle. The universe is not perfectly transparent. Between stars and galaxies drifts a thin mist of interstellar dust and gas. Microscopic grains of carbon, silicates, and icy molecules. These tiny particles behave like a cosmic filter. They absorb and scatter visible light, dimming the stars behind them the way a smoky room mutes a lamp. But the story doesn't end with simple blockage. When dust absorbs energy, it warms slightly and re-emits that energy at longer, invisible wavelengths, mostly infrared. To our eyes, it's as if the light just disappears into the dark. You can think of it like a giant universe-wide recycling system. Photons hit the dust, get soaked up, and are sent back out as a gentle heat glow that human vision can't catch. Telescopes that see in infrared reveal a sky blazing with this hidden radiation, proving that the night isn't truly dark. It's just glowing in a language our eyes can't understand. But even with all this filtering, there's yet another reason the night sky looks black. The limits of our own senses. Our eyes are tuned to a narrow slice of the spectrum, missing most of the cosmic light show entirely. Even when distant starlight survives the universe's expansion and slips past clouds of cosmic dust, there's a final barrier: our own eyes. Human vision is tuned to a narrow band of wavelengths, what we call visible light. But the universe radiates across a huge electromagnetic spectrum. Radio waves, microwaves, infrared, ultraviolet, X-rays, and beyond. Most of the energy racing through space isn't in that thin, visible slice. Imagine if we could see in infrared or radio frequencies. The sky would blaze with hidden heat signatures and distant signals. Telescopes like the James Webb and the Atacama Large Millimeter Array do exactly that, revealing a universe alive with light we'll never glimpse unaided. At night, when you see stars twinkle, you're catching only the brightest, closest photons in a flood of invisible radiation. The vast majority of the universe's glow is simply outside our biological range. So the darkness you sense isn't the absence of light, it's a limitation of perception. Yet, even with our limited eyesight, scientists have found a way to see one more incredible glow: the faint aftershock of the universe's birth itself. Long before the first stars were born, the entire cosmos was a blazing sea of energy. When the universe cooled enough for light to travel freely, about 380,000 years after the Big Bang, that ancient flash became what we now call the cosmic microwave background, CMB. This glow still surrounds us, filling every corner of space. It isn't visible to the naked eye because it's stretched into faint microwave radiation after nearly 14 billion years of expansion. But with special detectors, scientists can map it as a soft, uniform haze. Proof that the universe once burned far hotter and brighter than any starry night we see today. In a sense, the darkness overhead isn't truly dark at all. It's quietly lit by this ancient afterglow, a whisper from the universe's fiery beginning. Together with the finite age of the cosmos, the relentless expansion that redshifts light, the filtering dust, and the limits of human vision, the CMB completes the picture of why our night sky remains a deep velvet black, despite being filled with countless suns. Next comes the final thought: how this cosmic darkness is actually a sign of a universe that is dynamic, evolving, and still unfolding before our eyes. When you add it all up, finite age, expanding space, hidden wavelengths, cosmic dust, and the faint microwave afterglow, the dark night sky stops being a mystery and becomes a revelation. It tells us the universe isn't infinite and static, it's dynamic, always changing, with light still racing toward us from stars we'll never see in our lifetime. Every patch of black overhead is really a time machine, showing how far light has traveled, and how the cosmos keeps evolving. What feels like emptiness is actually overflowing with energy our eyes can't catch. Radio waves humming from distant galaxies, infrared warmth from dust clouds, and the soft CMB glow left by the Big Bang. So the darkness above isn't a void, it's evidence that the universe had a beginning, that it's still expanding, and that most of its brilliance lives in wavelengths we can't perceive. Next time you stare into that seemingly endless black, remember, you're looking at a living record of the cosmos, one that's still being written in light too ancient and too faint for us to see. The night sky's darkness isn't emptiness at all, it's a message written across the cosmos. Every factor we've uncovered, the universe's finite age, its relentless expansion, the stretching of light into invisible wavelengths, the filtering clouds of interstellar dust, the limits of human vision, and the faint whisper of the cosmic microwave background, fits together like a grand puzzle. Instead of revealing an eternal, unchanging cosmos, the black canvas overhead proves we live in a universe with a beginning, one that's still unfolding and rushing outward. Each pinpoint of starlight is a timestamp from the past, and every shadowed gap is a reminder of the vast distances and hidden energy beyond our sight. So the next time you step into a clear, moonless night, remember, the darkness you see isn't the absence of light. It's the ultimate evidence that the universe is alive, evolving, and far more luminous than our eyes can ever know.